and then I will get into the types of the two sample design, okay? So effect size is telling you essentially how much of a difference there is. So we hear a lot of research that tells us results. They tell us, oh, this is statistically significant. There's a significant difference. But a lot of times we don't hear, well, how much? Like, how much of a difference? Is this something that I need to change my behavior from here on out? Or is this just something like to take into consideration? One of an example of that is when it talks about red wine lowering heart disease, right? It's like, well, okay, how much? One, how much wine are we talking? And two, how much is it lowering my heart disease? Because also alcohol raises heart disease, right? So what are we talking about here? Does this mean that, you know, because I don't drink, certainly don't drink every day. There's no way. I mean, you know, we might have a couple drinks a week, if that, but I'm not, you know, it's like, do I need to start drinking red wine every night with dinner so I can have some cardiovascular protection? Or is the risk of drinking alcohol every night going to cause more harm than the potential benefits of the red wine? You know, it just, sometimes you're just like, well, like, how good is this study? So effect size attempts to tell us how big of a difference. Is this something that is really big? Do we you know, need to write home and tell our parents about this? Or is it just something that it's like, it's kind of, right? Especially like we always hear girls are so much better at verbal skills, right, compared to boys. That's actually a really small effect. You're not likely going to notice much of a difference. So that's something that we're like, kind of, but not really. Okay. Sorry, I hate all these emails that pop up. Okay, so Cohen's D. Okay, Cohen is the guy that came up with it. Let me close my door real quick. Cohen is the guy that came up with it, and he picked D. I don't know why. I'm sure your book talks about it. I'm sure he explains why it's D. Okay, so D is equal to our sample mean minus our population mean divided by our estimated standard deviation. Okay, so it's not a very difficult little calculation to do, because you already have your sample mean, you already have your population mean. You do this part when you're calculating your t, and you figure out estimated standard deviation in your route to figure out standard error, and then to calculate your t, right? So you will have this number there, okay, in your calculations. We have a general set value over here, or values, okay? If your D equals 0.2 and smaller or less, then we call it a small effect. If your D is equal to around 0.5, we call it a medium effect. And if your D is 0.8 or larger or bigger, we call it a large effect. In this, in our calculations here, we do not need to worry about negatives, okay? So let's just say, for example, we had 12.6 should have been our mean. For the other example, they told us 10 was the population mean. I only have my notes here, so I don't know what estimated standard deviation was for you guys, unless somebody has your notes there. When you did the 126, did you calculate it with 126? You did,
Yes.
Cassandra? Or okay, does somebody have that? Do you have this right here, your estimated?
I had got 2.76.
2.76?
Yes.
Okay. All right, so that's how we would have done the effect size for this example. Okay, we would have taken that 12.6 would have been our new sample mean based on you guys adding up 126, right? And the population mean was told to us it was 10. Just in case y'all are wondering, I'm going over the, these were the numbers from the test, okay? And then Cassandra told me she got estimated standard deviation of 2.76. So D would be equal to 2.6 divided by 2.76, right? The 12.6 minus 10 divided by 2.76. Oh, wow. So we got a D of 0.94. And that would mean that this was a large effect, okay? What that means for us is that there is a pretty significant difference between the people who took that assertiveness training or whatever it was compared to the national average, okay? So this person, whoever this lady was that was offering this assertiveness training, she could certainly have confidence that her training works. It tells us there's a large effect. The people that go through this training really do increase their assertiveness, okay? That's what effect size tells us. If she had a small effect, then I mean, for her business, she probably wouldn't be advertising that. But in the critical research, we might say, look, could it help you out? Yeah, maybe it could help you out. If it's a lot of money, maybe you don't want to spend your money on it. Okay. We kind of get we get stuff like that with like hypnosis and smoking cessation or losing weight. There's not much of an effect, you know. Can it work for people? Yeah. Does it work for most people? Who knows? Maybe not. Okay.
Can you, I'm sorry, can you repeat the definition for this?
Okay, so I was just getting to that, Natalia.
Okay.
So the definition that's listed here, I haven't talked about that yet, but kind of the overall feel of it is it's telling you how large of a difference or how large of an effect you're going to have if you find significant results. Okay, it's kind of telling you how much.
Right. How large of a large of a difference or effect will what? Sorry.
How large of a difference between the two groups, if you want to think of it that way, or how large of a difference between the means.
Means. Okay. Thank you. I just wanted to make sure.
Yeah.
Because I'm looking through the book and I can't find the definition, so that's why I asked.
Oh, okay. And so he probably has this definition here, amount of separation between two distributions. It might be in there as that. It might be effect size, and it might have that definition.
What page did you find it?
You know what? Effect size might actually be a lot earlier. Let me just look it up in the glossary?
Oh wait, I think I might have found it.
It's probably in an earlier chapter.
I think it's in chapter 10.
Oh, okay. Oh, with the one sample, it talks about that one, 176, 178.
But I guess not.
Yeah, let's see. I'll explain this definition right here, and what they're talking about. That this might just be a general kind of a general definition from other books. Do we not have a glossary? Oh, there it is. I'm like, where's the glossary? Error. Oh, in the glossary, which in your book starts on page 401, and it is on that first page, they call it the effect size index, and it says amount or degree of separation between two distributions. And so I'm gonna explain that. Okay. Are we ready for me to explain it? Okay. All right, let me draw. So let's say we have our sample mean right here of 12.6. Okay, that's supposed to be kind of in the middle. All right, so just work with me here that that's in the middle of this distribution. And that was our sample, and our sample mean of 12.6. Okay. The population told us that the mean was 10. I didn't draw very good, but that the mean of the population was 10. And so if we were to overlap the distributions, it looks at how far away those distributions are from each other. And so that's why I say I didn't really draw this very well, because an effect size of 9.4 would be really significant. The distributions would be really different from each other. Okay, more like that. There would be more separation. So if you have a small effect, the distributions usually have quite a bit, I didn't even do good on that one, but usually have quite a bit of overlap. Okay, and what that means when we're looking at this is there's all these individuals in here, right? Remember me saying that a long time ago? There's all these people in here. And there's plenty of people that even though they went through the assertiveness training, they still scored less than 12.6, right? Not all of them, I don't think anybody scored exactly 12.6, right? We had some 9s, we had some 10s, we had an 11 in yours, we had a 17 in mine, but we had people that scored less than 12.6. In the population, in the real population, when people were taking this assertiveness test, not everybody scores 10. There's plenty of people that score more than 10, right? So we're just looking at how much of these individuals that undergo this training are in this overlap. Is there a big overlap here? And if there is not very much overlap, then it would be very safe to say that the training really did bring those people along in their assertiveness. They really moved that whole distribution over, and it significantly raised their scores on that assertiveness training. When I talked about verbal skills, right? Girls, we always say, have a pretty high verbal score. And I don't know what that is, okay? Let's say it's 500. And we have boys. Well, boys are really very far along also, okay? And so if you look at this here, let me put my little means here. I don't know what the score would be for boys. I don't know, but let's say 480 or something. Oops. If we try and look at that overlap, right? There's a bigger chunk in here. There's quite a bit of overlap, meaning there's a lot of girls who are way down here, lower than the mean of the boys. And there are a lot of boys over here that are even on this side that are higher than the mean of the girls. That there's so much overlap that it's difficult to separate them. It's difficult to say, oh, the girls truly are better, right? It might come out statistically, and it might come out significant that the girls do score higher on average, but there's a small effect. It's not too much, if that makes sense.
Because, and you're saying there's a small effect because they're essentially overlapping almost completely to each other.
That's exactly right. Right? It's like there's so much overlap that it's sort of difficult to even see which ones are the girls and which ones are the boys. They would be so mixed up in there all together, right? Whereas if we look at this one, it's pretty easy to see. We have all these people over here that took that training, and man, it would be all over the place, right? And then over on this side, there's so many people in the regular population that are over on this side. It's clear to see the separation of these two distributions. It's very easy to see these are the people that took that training, and these are the people that did not. In this one, it's like, okay, there's girls over here and there's boys over here, but there's also a lot of overlap in the middle. Okay. So that's what effect size is. I think maybe, just understanding a large effect means it's really good, and maybe you should listen to what the results are telling you. If it's a medium, it's okay, it's good. It's still, I would maybe follow the results of that study and say, okay, this is something we should consider. If it's a small effect, it's like, maybe it was just something in the way you tested. Maybe you were kind of lucky to get positive or significant results. Maybe if we did this with a lot more individuals and we tested more and more samples, maybe we're onto something, or maybe we're not onto something. So, and again, this is just getting into, like, if you were moving forward with statistics, if you're going to go into research, effect size is important. But again, you don't hear very many people out in the real world talking about effect size. I think more and more it's becoming popular. You'll see it in studies, newer studies. In some of the older types of research, you probably won't see effect size. The other thing I want to mention is if you have a negative D, we don't care. We don't care about positive and negative in this, when we're looking at effect size. We only care about the numbers. So these could also be a negative 0.20, it could be a negative 0.50, or it could be a negative 0.8. We don't care about that. We're just looking at the magnitude of the number, okay? So because in statistics, especially in once we are, at this point from Z on, the negative is just telling us whether our sample mean is higher or lower than the population mean. Okay, so like in this example right here, our sample mean was a higher score than our population mean, so we had a positive. If those numbers had been flip-flopped, okay, if we had 10 here and 12.6 here, our D would have been negative. And it doesn't take away from, it doesn't diminish, it doesn't devalue our results. It's just saying the sample mean was lower than the population mean. Okay, so we don't need to worry about a negative score when we're looking at effect size. We're just looking at the magnitude of the number. Okay. How do we feel about effect size? Okay. Oh no. All right, well, it's saying I have 20 minutes of battery. So let me get into this real quick. Plus we're starting to push that hour. The two types of a two sample design, okay? And this is in contrast or reference to what we did last week. We did a one sample, meaning we just took one sample of people and we compared them to a population mean, okay? In these two types here, in this type of design, we're looking at two samples, okay? So the two ways you can do this are what we call a paired sample, or oops, I didn't mean to do that. What he calls a paired samples t-test. Sometimes some books call it related or dependent. Okay, so lots of different type or titles for the same thing. I think the best way to think about it is all these D's that you see. Okay, and that'll make sense in a little bit. Okay, so paired samples t-test, related or dependent. Okay, hang on to those D's. We also have a type where we call it an independent samples t-test. Okay, so those are your two types. Okay, let's look at the paired samples t-test. There are three ways to make our pairs because we're going to have two groups. Okay, our two groups, this is why I like dependent a little bit better, because our two groups are dependent on each other. Okay, or some people like paired. We're going to think of them as they're paired together. All right, so the first way is just what we call natural pairs. There is no intervention from the researcher. Okay, they just occur naturally. So here are some examples. Have you ever heard that people look like their dogs? I don't know, right? We could do a study like this. We could go to a dog park on Saturday and Sunday and take photos of people and their dogs and then run them through and have volunteers sit there and rate it, whether they really look like their dog or not. This would obviously be a natural selection. We would not go in and grab an individual and give them a dog and say, here, this is your dog. and we want to see if you look like each other. That makes no sense, right? As far as the design of the study, that doesn't make sense. For children, we're looking at IQ. Okay, if we want to know, who do they get their IQ from? I'll let you know. We believe it's from the mom. Okay, we believe IQ is more tied back to moms than dads. So if your mom ever says you're stupid, say, well, I get it from you, and then duck. No, I'm just kidding. Don't say that. And your mom should not say that to you. That's not nice. All right, so children's IQ. We would obviously go and give an IQ to the kids. We would give an IQ to the mom, and then we'd see whether they're correlated, right? We'd give IQ to the dad and see if that's correlated. We would not take a group of kids and then take a random group of women and see if those IQs are correlated. That makes no sense, right? That doesn't even make sense for the study, okay? Matched pairs. This is where the researcher does match people together. This is where there is purposeful, there's logic behind it, there's reason behind matching them. Okay, and so these are interesting studies too. So here's an example. A big study came out years ago about babies that were breastfed had a higher IQ compared to babies that were formula fed. As soon as that study hit the scene, researchers all over were just up in arms about it. They were like, what in the world? You can't make this claim. There's too many confounds. There's too many variables. This is not my idea. These are the variables that they came up with. They said, this is not me. They said, maybe moms who choose to breastfeed just have a higher IQ anyways, and that it's really genetics, it's not breast milk. Some people came out and said that women who are able to stay home and breastfeed forever, maybe they're more well off, maybe they're richer. And so maybe it's socioeconomic status that has to do with IQ, not whether you breastfeed. They said maybe it's just the amount of time spent with the child, because breastfeeding takes a very long time. A bottle, babies suck it down like that. So maybe it's just the amount of time and bonding that happens. So there were all these outside factors. So what they did, this is a really cool study, because you can't go in and force this. You can't go into all these brand new postpartum moms and take away their babies and say, okay, you guys are going to breastfeed, and the moms are like, I can't because I have HIV, and they're like, no, you have to. Or you're going to take these babies and say, you don't get to breastfeed them, you have to do formula, and they're like, no, I know the benefits of breastfeeding, I want to breastfeed, and you're like, no, you can't because you're in the study, you have to formula feed. It's unethical, you can't do that. So the best thing that you can do is match participants, okay? So you take moms who are going to naturally breastfeed on their own, and you find out all kinds of information about them. You get their IQ, you get their socioeconomic status, you measure how much time they spend with the baby. Do they work? Do they not work? And then you find a mom who's going to formula feed and match them. You get a mom that has a high IQ, high socioeconomic status, gonna stay at home with the kid, all of those things. And so you match them all the way. And when they're purposefully matched on IQ, socioeconomic status, time spent together, all of that, those factors cancel each other out, right? So from that study, the thing that emerged was genetics, right? It was the genetics that played a role, okay? I'm not saying that in any way to knock breastfeeding. I'm just saying if you formula feed or if you were formula fed, that did not have an impact on your IQ, okay? This other study right here, urban and rural men, they wanted to see, do men living in the city have a more open mind towards same-sex marriage than rural men, okay, men living out in the country. So some people were like, well, what do you mean? Like, it could be education, again, it could be education, it could be religion. You know, there's all these factors that could influence this decision of whether they're open to same-sex marriage. So they did that. They found a man that lives in the city that maybe is super religious, maybe not educated, and they matched him with a man that lived out in the country that was the same education and the same religion. Okay, they took all of those things and they matched people. And what they found was that men living in the city are more open to same-sex marriage. And what we really feel that that one is about is just mere exposure. Okay, the more you're around something, the more open and okay you are with it, compared to living out in the country where maybe you're not really exposed to that. Okay, so this one is matched purposefully. There's logic, there's a lot of thought behind, oh no, there's a lot of thought behind why the pairs are matched. Repeated measures is, it's the same individual doing both levels of the study. Okay, so we go through one time and then we do it again. Your best examples of these are any pre-test, post-test type scenarios. If I want to measure your on a racism scale, okay, so I give you a test before, and then I send you to a week-long camp where it's very diverse, and you're doing a lot of team building and getting to know everybody, and then I give you a racism test after that, okay? And so that could measure, you know, how did that week-long camp change people's behavior or racist views, okay? I always think about doing this for this class. Day one, giving you guys an exam that's asking you about paired samples and effect size and degrees of freedom and all of these things, and then test you on the last day and see how much you learn, right? The only problem with me doing that is I feel like a lot of people would drop my class if I gave you a test on the very first day, right? People would be like, oh my God, this is going to be too hard. But then they wouldn't know that maybe the test on the last day is actually just your final, and then it's super easy because you already know all that stuff. But that's a repeated measures, okay? Paired, we're going to get into this. Okay, this is how we calculate paired. I'm going to do this tomorrow, okay, guys? But I'll also wait till next week too, because I don't want to leave anybody behind. So we're going to do this. This is why I said hold on to the D. Okay, hold on to that D. What this D stands for is a difference. It's a difference score. What you're doing is you're finding the difference between this group and that group, which is like right here, okay? So we have to find a difference. This is where I like to say D is the new X, okay? So we're gonna have to calculate D, add it up, sum of D, we're gonna square it, and we get the sum of the D squared. So this is exactly what we were doing with our X's before, but now we're doing it with the D. Okay, so we'll go over this, don't stress. I'm scared my computer's gonna die. I just wanted to give this definition right here real quick. Independent samples t-test. These two groups could not be paired. It wouldn't even make sense to pair them. You can't pair them. The purpose of the study is to see the difference between them, okay? So this is if we want to compare men versus women, right? Boomers versus millennials. I'm just kidding, I don't know, right? Coke versus Pepsi, all right? You are purposefully looking at the difference between the two, okay? So that's independent samples t-test. And I don't have the formula here because I don't want to scare you. He's big, he's ugly, and he scares a lot of people. But you'll find out he's really just a nice teddy bear and he's not that hard. Okay.
Not pair Coke and Pepsi though.
How
Like
can
maybe
what?
the other ones I understand, but like Coke
Oh,
and Pepsi.
well, if you were